Hello my dear children, welcome to my channel Electrochemistry. Till now in electrochemistry part we have seen about galvanic cell and we reached it up to the salt bridge. Thus I want to continue the part from the salt bridge. So just now we have seen what does this salt bridge will do and how the salt bridge will help us to solve the problem. Because we have seen that in our previous cell, in galvanic cell, we have taken a two half cell. Let us say it is a oxidation half cell. This one is a reduction half cell. In this one we kept the zinc rod. Here we kept the copper rod attached with the bulb and all. Flow of electron from LHS to RHS, flow of current from RHS to LHS. Everything we have seen. Actually, what is the problem created here? This rod gets surrounded with a positively charged ions. At the same time, this rod is accumulated with the negatively charged ions. Now, as this positively charged ion, this won't allow the electrons to flow from this LHS side toward the RHS. And this negatively charged ion which is surrounded around the electrode won't allow this negatively charged ion to enter inside the rod. Because of that, flow of electron stopped, and because of that, flow of current was stopped. To solve this problem, what we have taken? We have taken salt bridge. Salt bridge, it is a inverted U-shaped glass tube containing inert electrolyte. What is the inert electrolyte? It may contain KCl, it may contain K2SO4, it may contain KNO3, or it may have NH4Cl. Any of these electrolyte present over it. Consider the salt bridge will contain the KCl. Means here, from here Cl minus will enter and from here K plus will enter. Consider this Cl minus which is coming from the salt bridge combining with a positive ion present around the electrode, and we know that this positive ion is nothing but a zinc ion which combined with the chloride ion, and it can form highly soluble salt of zinc chloride. At the same time, this KCl which is coming from K positive coming from here combining with the radicals sulfate, and it form K2SO4 highly soluble salt. Both the salts are highly soluble. Again it will ionize as a zinc ion and chloride, potassium and sulfate. But thing is that as soon as the chloride ion enter here, it will decrease the accumulation of positive charge around the electrode. As soon as this potassium ion will enter here, it will decrease the accumulation of negative charge around the electrode. As these ions decreasing the accumulation of these positive negative charge around the electrode, means here flow of electrons started and flow of current gets started. Means what is the use of salt bridge? We have seen that first point, it maintains electrical neutrality. It maintains electrical neutrality. This is the first important point. Second point also we can say about the salt bridge that it completes a circuit. It completes circuit. How? By flow of electrons. Means as the electron will flow, circuit gets completed. So this is the important functions of salt bridge. But the most important function, just now in my previous video I told you that I am going to tell you, but in this video I am going to explain you that it minimizes liquid junction potential. And in my today's video, my dear children, I will explain you about minimizes liquid junction potential. How it minimizes, that part we are going to see. So listen here, important function of salt bridge is that it maintains electrical neutrality, it completes circuit by flow of current, and it minimizes liquid junction potential. We are going to discuss this point, how it will minimizes liquid junction potential. So for this minimizing liquid junction potential, I will take the help of a small diagram present here. So this is the point I am going to explain you how this our salt bridge, how it will minimizes liquid junction potential. To explain this minimizing liquid junction potential, I will take help of this diagram. Listen here. Let us consider it is one of the cell, and this cell will be divided with the two compartment LHS and compartment RHS. It will contain the liquid, it will also contain the liquid. Consider this particular thing will have electrode, it will also have electrode. This one undergoes oxidation. Obviously oxidation means this will come out, this electrode which is made up of a metal, here this metal will come out in the form of positive ion. Let us say this metal which is coming here in the form of positive ion, this all positively charged ion get accumulated at this particular point. At the same time, it is a rod or it is an electrode which in where this what you can say, this positively charged and get attracted over there to reduction occurs, and remaining negative ion present in the liquid, it get accumulated over this part. So we can say, just now we have seen the galvanic cell, two half cell, one half cell on LHS, other half cell on RHS separately. But now I want to take the example, both are in a one container divided into two part. So because of this liquid here and because of these electrode which undergo oxidation, positively charged get accumulated over here, and it undergo reduction, negatively charged get accumulated over here. Negative charge coming from the solution, positive charge coming from the rod. Now during this process, what happened here, as we know, as we learn in physics, that when these two oppositely charged ions separated, so what will happen, the charge separation, wherever the charge separation is there, it will create a potential. Now you can see this potential which is created, it is due to what? It is due to this liquid 1 and this liquid 2. So we can say there is a charge separation between these two liquid, and due to the charge separation it will develop the potential. And we know that, as we learn in the physics, that this potential means it will move from this point to this point, because it will always move from positive end to the negative end. So it is a potential created by these two liquid, and we know this is a particular, what is the cell I have drawn here, it is nothing but it is example of our one of the battery. And consider this complete battery, let us say it will have 1.1 volt, and the potential which is created due to these charge separations, let us consider that it will have 0.1 volt. Due to this developed potential of 0.1 volt, the battery potential, which is actually 1.1, now it will be reduces to what? 1 volt. So we can see here, due to the potential which is developed between these two charge or between these two liquid, because of these potential, actual potential of battery was reduced. What is the actual potential of battery? We know that it is 1.1 volt. But due to this charge separation, it created a potential, and what is the potential developed by it? 0.1 volt. So what happened due to that? It will reduces the actual potential of battery from 1.1 volt to 1 volt. Now for that one, suppose if we will using here as a salt bridge, due to that what happened? Accumulation of positive charge, accumulation of negative charge on either side get reduced. As accumulation of positive negative charge on either side get reduced, potential which was developed here, it also reduces. It reduces means instead of 0.1 it goes to 0.0001, and due to that, instead of reducing the battery potential from 1 volt to 1 volt, it will reduces very less, means instead of 1.1 to 1 it will become 1.0001. That means here we can reduce what, due to with the help of this salt bridge, we can reduce the accumulation of positive and negative charge on either side, and it can minimize liquid junction potential. Due to that, there will be a very less reduction in the potential of battery. So this is a very much important function of our salt bridge. And just now I have discussed with you that our salt bridge will contain the inert electrolyte. What is the inert electrolytes are there? It may have KCl, K2SO4, KNO3, NH4Cl. But to which kind of the electrolyte we should be taken in the salt bridge, it should also have a conditions. So we are going to learn about one more part, that is conditions of electrolyte present in our salt bridge. It's a very important condition is that the electrolyte which we are using in the salt bridge, that it may be KCl or it may not be a KCl. Suppose if we are having a silver electrode present in our half cell, for this silver electrode we can say KCl should not be used. KCl should not be used. Why it is like that? think that if the KCl is an inert electrolyte present in the salt bridge, obviously it will form a K positive ion and it may form chloride ion. And we are having a silver electrode. Obviously this silver electrode means chloride ion will combine with the silver electrode, and what it can form? It can form a precipitate of AgCl. So what is the important conditions for the electrolyte should be used in the salt bridge? That the electrolyte is such a way that it should not be combined with conditions. I am going to write this one. Electrolyte must not be, or we can say, sorry, electrolyte should not be combined with, combined with electrode. I should say should not be combined with metal rod, or should not be combined with metal ions. It should not be combined with metal rod or metal ions. Example for silver electrode. What is the electrolyte? We can say for the silver electrode, that is KCl electrolyte should not be used. At the same time, not only for silver electrode, KCl should not be used for, we can say, if the electrolyte present in the cell, if electrolyte contains either silver ion, means if you have taken the silver electrode, kept in a salt of a silver ion, this one, or it may have a Hg2+2 ion, or it may have a Pb+2 ion. If this electrolyte contains these ions, for these ions our KCl electrolyte should not be used in salt bridge, because Cl minus will combine with all these things. Cl minus will combine with to form AgCl, Hg2Cl2 and PbCl2. These all precipitate it may form, and due to the formation of these precipitate, again the flow of electron gets stopped, indirectly flow of current will stop. So this is a much important conditions for the electrolyte which will be used in the salt bridge. So listen here, electrolyte should not be combined with, means we should use that kind of electrolyte, that the electrolyte should not be combined with metal rod or the metal ion present in our half cell. This is the first point. Second important conditions for this we can say electrolyte in the salt bridge, that the electrolyte should have, this electrolyte should have good ionic mobility. Good ionic mobility means the cation and anion should move very fast, and not only good ionic mobility, and they should have equal mobility of cation and anion. Means mobility of cation and anion should be same. It should not be like that cation will move very fastly, anion will move very slowly. It should not be like that. Both the movement, or we can say velocities of the cation and anion should be same, means equal mobility of cation and anion. So these are the two important conditions for salt bridge. My dear children, this salt bridge part is most important part, because even in the IIT mains, even in NEET, they used to ask us important functions. So we should remember about the important functions of salt bridge. First important point, it maintain electrical neutrality. Second one, it complete circuit by the flow of electron. Third one, it minimizes liquid-liquid junction potential. Second one, this electrolyte which we are using in the salt bridge, how it should be, that electrolyte should not be combined with, means the electrolyte which we are using in the salt bridge, it should not be combined with any metal rod or the metal ions. For example, if in that half cell we are having silver electrode, KCl should not be used. If in that half cell the electrolyte which one we are using, if it contain silver ion, Hg+2 ion, Pb+2 ion, in that case also KCl should not be used, because it will, this chloride ion from the KCl will combine with this one and to form its precipitate, which will make again to stop the flow of electron, which in turn stop the flow of current. And the electrolyte which we are using in our salt bridge, it should have the good ionic mobility and equal mobility of cation and anion. So this is the part I am going to I have discussed with you about the galvanic cell and even in the salt bridge. Now in my next video, I will discuss about what is electrode potential and how the electrode potential we can understand about the standard oxidation potential and standard reduction potential. Before going to understand about standard oxidation potential and reduction potential, we'll learn actually what is mean by electrode potential and how it was created. That part I am going to explain you in my next video. Thank you very much. My dear children, if you like my video, please share it, subscribe it, and if it is possible, please write a comment. Write a comment that in which way I can improve my video for you. Thank you very much.